Okay, good day to you. Today, as we have discussed, we are going to start with, we are going to continue from where we stopped on pictorial drawing. The second part is oblique drawing. We have treated isometric projection. Isometric projection has to do with making reference to three axes to draw your block. Three axes, the two receding axes are 30 degrees to the horizontal and the vertical axis. But now in oblique axis, as said earlier, they are going to stick three axes. Look at, for example, looking at this block here, there are three axes that define this block. There is a receding axis to the left, there is a horizontal axis, and there is a vertical axis here. Yes, the horizontal axis. So this horizontal axis is the one we are using in place of the right receding axis in isometric. Another thing is that the receding axis here is not at 30 degrees to the horizontal, it is at 45 degrees to the horizontal. Okay, so instead of having two receding axes at 30 degrees to the horizontal, instead we're having just one receding axis, either to the left or to the right. The receding axis could be to the left, as we can see here, or could be to the right, as we can see here. So we have a receding axis, and then we have a vertical axis, and the third axis will be lying on the horizontal plane. The third axis will be lying on the horizontal plane. Now there are two methods of drawing oblique drawing, oblique projection. The first one is Cavalier oblique, while the second one is called cabinet oblique. But cabinet oblique is what is adopted now. The reason why we don't use Cavalier oblique is because when we draw it, the block will look distorted, will look deformed. In Cavalier oblique, all the measurements are to be made completely. It is meant to be drawn in full size. For example, this length 60 millimeters is to be measured 60 millimeters. Everything should be measured as seen here. But in cabinet oblique, the receding axis is meant to be drawn half the original size. For example, this length is 60 millimeters, but when you want to draw it, you draw it at 30 millimeters. That is to avoid distortion. Okay, so the cabinet oblique was invented because the Cavalier oblique was observed to look distorted after the drawing. So we are going to use the two methods, and then we are going to see which one is the best for ourselves. So first we are going to draw to scale, the full size scale, which is Cavalier, and then we are going to draw the receding axis to half size, which is cabinet, and we compare and see which one looks better. So let's start. This is the block we want to draw. This is the block we want to draw in Cavalier and then in cabinet. Now, the first thing to do is to draw the oblique axis. As you can see, the oblique axis, the receding axis here is to the left. So we are going to draw these three axes first. That's what we are going to start with. So first thing, I will draw the horizontal axis. Then I'll draw my vertical axis. Say my vertical axis is around here. Okay, so I will draw at this point now. I will draw my right receding axis using my 45 degrees. Remember, we said this is 45 degrees, so you are going to use 45 degrees set squares, not 30 degrees set square as you did with isometric projection. So we are using 45 degrees set squares. Place it on your set square perfectly, and then draw the receding axis. It's going to the left. So the third axis is automatically drawn. It is lined on the horizontal plane. So I will just erase this. I will erase this so that the 3 axes will be seen visibly. So we can see the 3 axes now. So let's mark the length. So the length of on this axis is 60 millimeters. The length on this axis, let's use the full length first. The full length is what? 65. Okay, and the length on this axis, the one we can see immediately, is from here to here, which is from here to here, 20 plus 10, that is 30. So I'm going to mark the 3 now. So I'll measure 60 on this preceding axis, 60 millimeters. I'll mark 65 on this one. Then I'll mark 30 on this vertical axis. Okay, so that's what we have. And as you can see here, this is we have marked our 60 here. So from this point where we mark 60, there's a vertical line going up. And here, at this point where we marked our 65, also there's a vertical line going up. So we draw the 2 vertical lines at those 2 points. So I'll draw a vertical line at this point. I'll also move to this point and draw a vertical line. Just follow the lines of the given drawing. So what's the height of this? Okay, we already have the height here. The height which we have measured here is what? Is 30. So from this point where we have 30, we have a line parallel to this receding axis, parallel to the receding. So we are going to use our 45 degrees to draw this one as well, so that it will be parallel to this. So let's do that. So I use my 45 degrees at this point where I marked my 30. Draw this. Okay, good. Okay. Now, just want to make sure that you are seeing what I'm doing. Now, what do we see here again? What can we see? So from this point here, there's a line parallel to the horizontal, and from this point also there's a line parallel to the horizontal. So I'll draw these 2 lines parallel to the horizontal at this point and this point. So I'll use my T-square straight to draw the 2 lines. I'll draw this first, and then I'll draw this one as well. Okay, but I need to know the length of these lines, so I'll just erase this one. I'll erase this as well. So what's the length of those lines? The length of this line is 20 millimeters. So I only need this to be marked 20 millimeters. So I'll mark the 20 millimeters there. So I'll use this to mark 20 millimeters. This is my 20 millimeters. Okay, and from that point, as you can see in the drawing, from this point where I mark my 20, there's a line parallel to the receding. So I'll draw this line also at 45 degrees because it's parallel to the receding. So I'll use my 45 degrees set square again to draw this line touching this. Okay, so I think I can erase this now. I can also erase this for now. I might need it later anyway, but let me just erase it for the sake of this tutorial. Now, from this point here, which is this point, there is a vertical line going up, and the height of that line is just 5 millimeters. So, and at this point also, which is this point, the same vertical line. So vertical line here, the height is 5 millimeters. So I will place my 90 degrees edge, draw this vertical line up, come here also, draw the vertical line up. So we say the height of this is just 5. So I'll just mark my 5 millimeters here, which is 0.5. And then from that point, I will draw this line parallel, still parallel to the receding as it is in the drawing, which is this. Okay, you see after this 5, can you see this line also parallel to the receding, which is what I just drew here. So I can erase this one. I can also erase this excess. Now after this, now there's a line parallel to the horizontal here, this line and this line, so we'll draw the two together. So I'll use my my t-square, slide my t-square to this point, draw this, slide it to this point as well, draw this. Okay, so what's the length of those two lines? The length of this line is 25 millimeters, so I'm going to measure 25 millimeters there. I just need to mark one. You don't need to mark on the two lines. That is my 25, and from that point I'm going to draw a line parallel to the receding, which will connect the second line parallel to the receding. You can see parallel to the receding, so it's connecting this one here. So we have this point, so I can erase this as well, and this also. Now what else can we see here? So from this point now there's a vertical line coming down, and then there is a horizontal line going, so I'll do these two together. So from this point there's a vertical line coming down, and then there's horizontal line. So I'm just going to use the horizontal line is a continuation of this one, so I'm just going to slide to this point and continue from here. So I think we are on the way. So the horizontal line is which we just drew here, is a continuation of this one, so that's why I just continue it here. So at this point now there's another line which is a continuation of this one as well. Okay, so there's another line here at this other side, which is this. Can you see it is a continuation of this one as well? So I'm going to use my t-square, slide to this point, and then extend it to the other side. Extend this line to the other side. Okay, now to complete that part, now from this point, which is this point, there's a receding line at 45 degrees. So I'm going to use my 45 degrees set square, slide it to this point, and then draw this. Okay, then I will erase this part. This one also. Let me erase this one also. So we're almost done with the drawing. Now I need to shape this in the inner part of this. So from this edge you can see this is 10 millimeters, and from this edge also 10 millimeters in, and then from those points there are vertical lines going up. So I'm going to draw this, mark these points. So from this edge here, 10 millimeters from this edge, also 10 millimeters from this edge, and then from those 2 points there are 2 vertical lines going up. So I'm going to place my 90 degrees edge at those points and draw the vertical lines. Okay, so what's the length of these vertical lines? What's the length of these vertical lines? The length of this is just what? From here to here is 20. So I'll mark 20 on one of the lines. I don't need to mark the 2 lines, just mark one of the lines and then I'm good. So this is 20 here. So from that 20, I'll draw the horizontal line to connect the second one. Okay, so that's it. So the inner part of this line is useless, so I will erase it. Now there's one more line which is missing there, which is this line. this line is also parallel to the receding, that is 45 degrees. So I'll slide my T-square closer, then use my 45 degrees set square to draw the line at this point. Okay, that's it. That's it. So the only thing we need to do now is to outline the drawing and see what it's going to give us. So let me just quickly outline the line. Okay, so as you can see here, I have successfully outlined the block. So look at this now. This is what I want you to know. Look at this length. This length is meant to be 60 millimeters, and this length is meant to be 65. So which one is longer? This is supposed to be longer, but from the look on the block right now, the drawing right now, we can see that this one looks longer than this, which is not normal. So that is why the invention of the second method was necessary. So this one looks distorted, looks longer than usual, than it's supposed to be. So that is why the cabinet oblique method was invented. So we are going to draw this same block in cabinet, and then we'll compare the drawing and see the difference. Thank you for watching.